Hey guys, welcome back to How It Works. Today we're going to be talking about Git. Git is a distributed version control system that keeps track of changes to files over time. But how does it work?
Let's start with the fundamental data structure that Git uses, called a commit. A commit object is a data structure that contains metadata about a particular snapshot of your project at a specific point in time. When you make changes to your project and commit them in Git, a new commit object is created to represent that snapshot. Each commit points to a parent node, thereby making it a linked list. In the Git linked list, there are two pointers that are important to understand. The branch pointer, in this case, the main branch, and the head pointer. The branch pointer serves as an identifier and entry point into a specific branch, and it remains fixed unless you explicitly move it. On the other hand, the head pointer is a dynamic pointer that indicates the current snapshot or node of your work in Git. When you make changes to your project, these changes are added on top of the node that the head pointer is currently pointing to. This means that the head pointer is constantly changing as you make new commits, and it plays a crucial role in allowing you to keep track of the changes you've made and the history of your project over time. Each commit object contains the following information: a unique identifier, a long hash string that identifies the commit and distinguishes it from all other commits in the repository; a timestamp indicating when the commit was made, the name and email address of the person who made the commit, a commit message that describes the changes made, a pointer to the previous commit that the new commit is based on, a tree that represents the state of the entire project at the time of the snapshot. The tree is a hierarchy of file and directory objects, each of which represents a file or directory in the project. But how does Git know what changed between commits? Git uses a hashing algorithm to create a unique ID for every file in your project. When you make changes to a file and commit it, Git calculates the hash of the file and compares it to the previous version. If the hash is different, Git knows the file has been modified. Git also uses a powerful algorithm called data encoding, or data compression, to store only the changes made between commits, rather than storing the entire file again. This makes Git incredibly efficient, even for large projects with many contributors. And when it's time to merge changes from different branches, Git uses a three-way or two-way merge algorithm, sometimes called fast forward. A two-way merge is a type of merge in which Git combines two branches that have diverged from a common ancestor, but changes do not overlap or conflict with each other. Basically, you're just changing your main branch's pointer to point to the end of your feature branch. A three-way merge involves using a dedicated commit to combine the two histories of different branches. This type of merge gets its name from the fact that Git uses three commits to create the merge commit, the two branch tips that are being merged and their shared ancestor. The merge commit serves as a point in history of the project where the two branches were brought together, and it contains all of the changes from both branches.
And that's how Git works. It's a powerful tool that relies on some pretty advanced algorithms to keep track of changes in your project. Thanks for tuning in to How It Works. I'll see you next time.